Hey everyone, welcome. Today we're working on the interval questions from the LeetCode roadmap. So intervals are actually very basic data structures. They have a start and an end, and the interval is basically something that's between the start and the end. So the only real operation we can do on an interval is to check for overlap with other intervals. So for example, if we have one interval that ends before another starts, then we have an overlap there. So most of these questions, for example, insert interval, merge intervals, they all revolve around the idea of checking for overlap. And for example, if we have overlap, then we want to merge them. Or in cases of non-overlapping intervals, if we have overlap, then we want to remove one of them. So later on, we're going to get to more difficult questions like minimum interval to include in each query. So this doesn't really revolve around the idea of overlaps. Instead, it uses some previous data structures that we talked about to solve this hard question. So without further ado, let's get into the first question, merge intervals. So merge intervals is actually the second question on the roadmap. I decided to put it first because insert intervals is basically merge intervals with a twist. So let's do merge intervals first. So looking at merge intervals, we're given an array of intervals where intervals I has start and end, just like I said. And we want to merge all the overlapping intervals and return an array of the non-overlapping intervals that cover all intervals in the input. So what does that mean? So looking at, let's drag this test case down. Looking at example 1 here, we have intervals 1, 3, 2, 6, 8, 10, 15, 18. So there's an overlap here because 1, 3 ends after 2, 6 begins. So these two should be merged into a single interval starting from 1 and ending at 6. After that, we can just return that as the output. Note these two intervals became 1, starting from 1 and ending at 6. So in example 2 here, we have two intervals, 1, 4, and 4, 5. So there's no strict overlap, but they both share this number 4. So this question wants us to merge these, if they have the same start and the same end, into a single interval. So in example 2 here, we're going to return the output 1, 5. These two are going to be merged into a single interval because they both have 4. So in this case, this is considered overlapping. So we want to merge the intervals so that there are no overlapping intervals in our output. So let's actually get a diagram here of some intervals to look at. So for example, we have interval here, we have another interval here. Because these two are overlapping, we want to return the final interval, which starts at the start of the first interval and ends at the end of the second interval. So this is what an interval merge will look like. So we can have another case where we have a big interval and a small interval. So these two merged is basically just going to become the big interval. So these are the two cases. One case where we have two intervals, one starts earlier, one ends later. So we join them together to form an output. Another case is that we have one interval that completely encompasses another interval. So their merged output is just going to be the bigger interval. So how should we do this question? Well, first we should sort all the intervals based on their starting time. So in the examples, they're already sorted, but we don't know that if it's actually sorted in all the test cases. So we want to sort the intervals so we can go from the start to the end in a single iteration. So to do that, we'll do intervals.sort. And to sort it based on the start time, we want to sort it on the start time, not the end time. So the key should be lambda x, where x is the first element. Because the first element is going to be the start time, the second element is going to be the end time. So now we want to have an output. Let's call that merged. Merge is going to be an array of arrays, or a list of lists. So now looking at these intervals that are already sorted, so for interval, for start, and in interval, so we have the start time and the end time of every single interval. So now we want to see what should we do with this new interval, the new start and end time. So first, we should only do merge operations if there already exists intervals inside merged. So first we should check that len merged is greater than 0. What else should we check? We should also check that the end time of the merged is greater than the start time of our current interval. So this is the case where we have overlap. So how do we get the end time of the last interval in merged? That's going to be merged at -1, so the last element, and at index 1, which represents the end time. So we don't have to worry about any intervals before the last one. For example, if there's previous ones in merged, that doesn't really matter because we know the merged intervals are already sorted and everything in merged is already merged. So there's not going to be any overlap there. So if we have the case where there's elements in merged and the end time of the last element is greater than or equal to our start time. So note that in the case where we have 4 and 4, we're going to merge them. So we're doing greater than or equal to here. So in this case, if we have overlap, we want to merge them. How do we merge them? Well, the end time of merged should be set. The end time of merged, remember, is this. Merge the last element at index 1. This is going to be our new end. But remember, we have two different test cases. We have two different cases here. One case where the end of the new interval is actually our end. So note that this here is end. So it's also possible that the end of merged is already the correct one. So end is here. Oops. So when do we want the end of the merge interval to be our actual end variable here? We only want it if n is smaller than the end of merged. So instead of just setting it to n, we're doing a max case. So it's going to be the max of merged at -1, 1. So for example, if this end is greater, so the end that's already in merged is greater, we're going to use that. Otherwise, if our variable end here is greater, then we're going to use this. So now we guarantee that we have the longest merged interval and we insert that at the end of merged. So else if there's no overlap, so the if case is if there is overlap, the else means there's no overlap. What do we do if there's no overlap? Well, we can just insert our interval in. So merged.append, we append our interval as start and end. After that, we can just return merged. So this is going to be our algorithm to merge all the intervals. Let's try running it. Cool. Yeah, so that's this question. The only tricky part here, I think, is what we set the end of merged to, because there's two different cases, so we want to consider the maximum number, because we don't want the merged interval to be shorter than the longer interval. So moving on to the next question, insert interval. So in insert interval, we're given an array of non-overlapping intervals where intervals I is start end, just like before. And it's already sorted in ascending order by start, so you don't have to sort it this time. Now we're also given a new interval with start and end that represents the start and end of another interval. So what we want to do is insert this new interval into intervals so that it's still sorted by ascending order and it doesn't have any overlapping intervals. In this case, we want to merge these overlapping intervals if necessary. So now we want to return intervals after the insertion. So we already know how to merge intervals based on the previous question. So the only trick here is we have to insert the new interval. So because intervals is already sorted, we're going to have to look for a place to sort this new interval. And to do that, we can use a binary search trick to see where start belongs, because intervals is already sorted by their start. So we want to add the new interval based on its start into the intervals array. So to do that, let's do a simple binary search here. L and R equals to 0 and len intervals. So while L is less than R, we're going to search for the midpoint. So mid equals to L plus R divided by 2. So if intervals at m, so the mth interval or the middle interval, and it's 0, index 0 is referring to the start position. So if start is less than new interval's start, what should we do? Well, we should move the left pointer to the middle plus 1. So L equals m plus 1. This is the same as every binary search approach we've done before. Otherwise, R equals to m, so otherwise we move the right pointer to the middle. This is because if the starting point of m is less than our new interval, we want to search the larger side of intervals, otherwise we want to search the smaller side of intervals. So now L is going to be equal to R, and intervals at L is going to be the position we want to insert our new interval. So let's insert that into intervals. So intervals equals to intervals from 0, 0 all the way to L. This is non-inclusive. So at the element L, we're going to add our new interval, cast into a list, plus intervals, everything from L and onwards. So now we have the new interval inside of our intervals list. So now we just run our merge approach because we don't want any overlapping intervals, just like the previous question, so we can run our merge and return that. And it's already going to be in sorted or ascending order based on the starting position because everything in intervals is sorted and our new interval is inserted at the right position. So we don't have to worry about the order here. All we have to worry about is merging it, and we can do that just like the previous question. So to do that, let's create a merged list, and for start, end in intervals, just like before. So if there's overlap, what should we do? We should do if len merged is greater than 0. So we only want to care about this if there's already intervals in merged, and the last timestamp -1 at 1. So the end of the last interval in merged, this is greater than or equal to start, in which case we want to merge. So to merge, merged at -1, 1. So the last index's end time is going to be the greater of the last index's end time, -1, 1, or our new variable end. Otherwise, if there's no overlap, then merged should just append our start and end. Cool. So we can just return merged afterwards. And it's already going to be ascending order like we justified before. So let's try running that. Nice. Cool, so this question is super similar to the previous question. The algorithm here for merging is the same. The only trick here is we have to insert the new interval at the correct position. So we did a binary search here to find the position and then insert it at that position. So if you don't want to do a binary search, you can also iterate through intervals to look for where we want to insert the new interval. That would work as well. Because merging intervals is already going to be an O of n time based on the number of intervals. Since we're iterating through intervals, it doesn't really matter if we use a log n or O of n approach for adding that new interval. But log n is a little bit faster. So moving on to the next question, we're going to do non-overlapping interval. So given an array intervals where intervals I from start to end, we want to return the minimum number of intervals we have to remove to make the rest of the intervals non-overlapping. So looking at example 1 here, we have 1, 2, 2, 3, 3, 4, 1, 3. So these intervals here, they're considered non-overlapping. Even though they share the start and end time, they don't actually overlap according to the definition of this question. So we only remove them if there's strict overlapping. So in this question, we want to remove 1, 3 because this interferes with all the other intervals, and it's removed, so the rest of the intervals are non-overlapping. These 3 are okay, so we remove 1, 3. In example 2 here, all of these are the same interval, so we have to remove 2 of them and keep the first one. Or it doesn't matter which 2 remove, but we have to remove 2 of them. So in example 3 here, 1, 2, and 2, 3, they're already non-overlapping because there's no strict overlapping, so we don't have to remove any interval, so return 0. So this question, although it looks pretty difficult, it looks like there's many different cases to consider. It's actually very similar to our first question, merge intervals. So in this case, instead of merging the intervals, all we have to care about is whether or not we have overlap. And we can check that based on the if condition we did in the merge intervals question. So if there is overlap, well, we have to remove one of the intervals at least. So for example, if 2 intervals are overlapping, for example, 1, 2, and 1, 3, we're going to have to remove one of them. But which one should we remove? We should remove the interval that affects the least other intervals. So 1, 2 affects no other intervals, whereas 1, 3 also affects this 2, 3 interval. So which one should we remove? We should remove 1, 3 since it affects the most other intervals. So to do that, let's start off by sorting our intervals. So intervals.sort. The key is still lambda x, where x 0. So this basically sorts it based on the start position. And we need to keep track of the number of intervals we removed. So removed equals to 0 at the start. And we should also keep track of the last interval in merged. So before we need to keep track of all the merged intervals and we want to return that. But now we don't have to keep track of merged. All we have to keep track of is last, or the last interval that is in front of our current interval, because that's the only interval that could possibly overlap with our current interval, since everything else is already dealt with or removed. So let's iterate through intervals just like before. So for start and end in intervals. So if last is not equal to the empty list, so basically if this is not the first interval we're searching, then it's possible we have an overlap. So when do we have an overlap? Well, if last one, so this is the end position in last, is greater than start. Notice that we're using a strictly greater, not greater than or equal to like before, because in this question we're allowed to share a start and end time and be considered not overlapping. So this is our overlap condition. So if we have an overlap here, what happens? Well, we want to set our last one to be the smaller of the two end times. So the end, for example, 1, 2, and 1, 3, they have end times at 2 and 3. We want our end time to be the smaller one and remove the interval with the larger end time, because that's going to affect the most future intervals. We don't want to affect future intervals, so we're going to keep the smaller end time. So last one, this is going to be equal to the minimum instead of the maximum here. So last one and end. Before we want the maximum, since that's going to be the end time of the merged interval, now we want the minimum, so we affect the least future intervals. And whenever there's an overlap, we have to remove one of the intervals, so removed plus equals to 1. Otherwise, if there's no overlap, then last should just be our current interval. So last is start, and because future intervals are, previous intervals, they don't matter since they're already dealt with, or they have been removed. So in this question, we have to return the number removed, so just return removed. Let's try running that. Cool. Nice. So this question, it seems pretty difficult at first, but the only real difficult part here is actually figuring out which interval to remove when we have a overlap. Because when we have an overlap, we have to remove at least one of the intervals. So we're going to see which one is more beneficial for us to remove, and we're going to remove that one, keep track of the number removed, and return that at the end. So moving on to the next question. So meeting schedule. So in this question, we're given an array of meeting time intervals, object consisting of start times and end times. So we want to determine if a person could attend all their meetings to the schedule without any conflicts. So this question is again quite similar to merge intervals. Instead of merging interval when we have an overlap, it's actually easier this time. We just return false. Otherwise, we'll go to the end and return true if we can attend all meetings, or in other words, there's no overlap. So again, this question is actually testing us on whether or not we can find overlaps in intervals. So here, intervals, instead of a 2D array, it's actually an object. This object has a start and end attribute. But if we want to reuse the code from before, we could just do this. So we cast it back into our list. So intervals, instead of having an object, we'll say it's i.start, i.end into a list for every interval in intervals. So now we can sort it just like before. So intervals.sort, and the key should be lambda x0, so sorting based on the start time. x0 is the start time. So now, just like non-overlapping intervals, we don't have to keep track of all the previous intervals, we just have to keep track of the last interval, because that's the only interval we can have a conflict with. So last at the start is going to be nothing. So for start and in intervals, we want to check if, first of all, we should do a null check on last, so if last is not equal to empty, and we have an overlap, so this is the overlap case. And last one, so the end time of the last interval is greater than the start time. So this question, again, it says 0 to 8, and 8 to 10 is not considered a conflict at 8. So this is completely okay, which means we don't want to do a less greater than or equals to, we just want to do a strictly greater than. So if this is the case, the previous meeting ends after the current meeting starts, then we have an overlap, in which case we want to return false. Otherwise, the last meeting is going to be this meeting, so last equals to start end. And then we go on for the rest of all the intervals. So after iterating through all the intervals, if we haven't returned false, if we didn't get an overlap, that means we can return true at the end. So return true. This means we can attend all the meetings. So let's try running this. Cool. Let's submit it. Nice. So this question is actually easier than all the previous questions. It's kind of like non-overlapping intervals. Instead of having to do an if case where we decide which interval to remove, we can just return false when there's an overlap and return true if we didn't detect any overlaps in all the intervals. So moving on to the next question, meeting schedule 2. So in this question, we're given an array of meeting time interval objects consisting of start and end times just like before, and we want to find the minimum number of days required to schedule all meetings without any conflicts. So let's look at some examples here. In example 1, we have 0:40, 5:10, 15:20. So there's a conflict here. Obviously 0:40 conflicts with 5:10 and also conflicts with 15:20. But notice that 5:10 and 15:20, these two don't conflict. So these two can be scheduled on the same day. So in our explanation here, 5:10 and 15:20, they're scheduled on day 2, whereas on day 1 we have 0 to 40. So it takes a total of 2 days to schedule these these meetings without any conflicts. So in example 2 here, we only have one interval, so we can just return 1 because it takes a single day. And again, 0:08 and 8:10 is not considered a conflict. We care about strictly overlapping, not just overlapping with sharing start and end times. So in this question, it seems more difficult, or at least more tricky than the previous questions, and it is. So in this question, we're actually caring about the maximum number of days, which in other words is the maximum number of intervals at a certain time. So for example, at any time between 5 and 10, there's going to be 2 intervals within this time, so we need 2 days. For example, 15 and 20, again, there's 2 intervals. So if we draw a little diagram of our intervals here, so suppose we have some intervals that look like this. Those two aren't overlapping, so we have another one, we have another one. So if our intervals looks like something like this, how many days is required? Well, an easy way to look is actually just drawing a straight line down, a vertical line, to see how many intervals we can hit at a time. So for example, if we have a straight line down where my cursor is, this is going to be 4 intervals. So these 4 intervals all happen at the exact same time, which means we're going to need 4 days to schedule these meetings. So our answer should be 4, which is the maximum number of intervals we can hit with a single vertical line going up and down. So how do we determine the number of meetings at a certain time? Well, we can look at all the timestamps that are in intervals, which is all the start times and all the end times. So whenever we have a start time, then the number of meetings during this time increases by 1. So for example, at index 0, the number of meetings increases by 2 because we have 2 meetings starting then. So we have 2 all the way until here at interval, interval 0, 1, 2, index 2. Index 2, we are introduced to a new interval, a new meeting, so the number of days required becomes 3. But then at index 0, 1, 2, 3, here, this meeting finishes. So the number decreases by 1, but again, we get a new one. So again, it's still 3 days until we get to this timestamp where we're introduced to a new interval. So now it's 4 days, and then this interval, this meeting stops, this meeting stops, this meeting stops, and at the end we have 1. So basically we're looking at all the timestamps whenever we have a new interval or whenever an interview starts. We increase the number of meetings by 1. Whenever one ends, we decrease that by 1. And all we have to check is the maximum number of intervals at a given timestamp. And we want to return that. That's the number of days required to schedule all the meetings. So with this diagram in mind, first of all, we can change intervals to how LeetCode does it. So intervals equals to i.start, i.end, .end for interval in intervals. And in this case, sorting or not doesn't really matter. We just care about the start and end times. So let's create some variables, max meetings. This is going to be the number of days or our answer, and also the current number of meetings, which is both of these are going to be initialized to 0. So all the timestamps that we care about are the timestamps we're introduced to new meetings or new intervals or where intervals end. So let's create a times variable. This is going to be a list, or actually it should be a set because it's possible we have duplicate times, so we don't want multiple of those. And we should also create change. Change is the change in number of meetings. For example, change at 0, this should be 2, positive 2 because we're introducing 2 meetings. But change at, for example, this index should be -1 because we're losing 1 interval. So to do that, this is basically a dictionary mapping times to a number, a positive or negative, so we can use a counter, which is basically a dictionary for numbers in Python. So now for every time interval in intervals, so for start time and end time in intervals, so change at start time should increase by 1, starting from 0. Because at start time, we're introducing a new interval. So the number of intervals should increase by 1, or the change should be +1. So opposite to that, change at the end should be decreasing by 1 because the number of intervals we have decreases by 1. And we should also add this start time and end time to times because those are important timestamps where intervals change. So times.add, add start, and times.add end. So these are now in our timestamps. So now we can take a look at what we have in times and iterate it from start to finish. So for time in, so times should be sorted and it should also be cast to a list. So for time in sorted list times with a plural. So the number of meetings we have at a current time, meetings should change based on what change is. So the change counter, which is the delta for the meetings. So meetings plus equals to change at the current time. And the maximum meetings, or the number of days required to schedule all the meetings, should be the maximum of any meetings during every time. So max meetings equals to the maximum of max meetings, or our current number of meetings. And as our answer, we want to return the number of days required, which is going to be return max meetings. Let's try running it. Cool. So this question is a bit of a different approach. We're not looking for overlap like we did before in the traditional sense. Instead, we're looking at the change in number of intervals during any present time. Whenever we are introduced to a new interval, change should increase by 1, otherwise it should decrease by 1. This helps us keep track of how many intervals we are in during any given timestamp. And then we look for the timestamp with the maximum number of intervals we're in, or the maximum number of meetings, and return that as our answer, because that's the number of days we need to schedule all the meetings without any conflict. So that's this question. Moving on to the next one. Minimum interval to include each query. Okay, so we're given a 2D integer array intervals I, left, right, just like before. We start at left and end at right. So the size of an interval is defined as the number of integers it contains. So basically right minus left plus 1. So we have an interval of 1, 2. It contains 2 integers, 1 and 2. So the size of that is going to be 2. So we're also given an integer array of queries. The answer to the jth query is the size of the smallest interval I, such that left I bounds queries j, which is bounded by right I. So basically the query, for example, if the query is 2, then the interval 1, 2 would bound it, because these are all inclusive, less than or equal to and greater than or equal to. So if no such intervals exist, so the query doesn't fall under any interval, then we want to return -1. And we want to return an array containing the answers to the queries. So let's look at an example here. This question is not very well explained. So intervals 1, 4, 2, 4, 3, 6, 4, 4. So we have the query starting at the index 2. So we want the smallest interval containing 2. So 2 falls under 1, 4, falls under 2, 4. It doesn't fall under any of these, so we don't consider them. So out of 1, 4, and 2, 4, which are the intervals that contain 2, which of these is smaller? So which of these contain less integers? Well, 2, 4 is smaller because 4 minus 2 plus 1 is 3. So we add that to our answer. So the answer at index 0 is the answer to the query of index 0, which is going to be 3. So now we're querying 3, which intervals include 3? Well, there's 3 intervals that include 3, all of these. So which one should we do? Well, 2, 4 is still the smallest one. All of the other ones include 4 numbers, whereas 2, 4 includes 3 numbers. So we're going to return 2, 4, or the size of 2, 4, which is 3. So if we're querying for 4, this interval has a size of 1. It only includes the number 4, so we're going to return 1. In query 5, there's only one interval which contains 5, which is 3 to 6. In which case we return the size of that, which is 4. So in example 2, we also want to look at the case where we return -1. This means we can't find the number inside of any interval. For example, 19 here. 19 is not in 2, 3, not in 2, 5, not in 1, 8, and not in 20 to 25. So 19 is not in any interval, which means the answer to that query is going to be -1. So that makes more sense now. For every query, we want to find the minimum interval that contains this number in it. So to find the minimum, first of all, we look at the size of these. Intervals 10 to the power 5, queries 10 to the power 5. So basically, we want to answer every query in constant time. Otherwise, we're going to get a time limit exceeded. 10 to the power 5 is pretty big. We don't want to have a n squared or n log n approach. Or actually, n log n is okay. We don't want an n squared approach. So a way to answer all the queries in not constant time, but instead log n time, is to use a min heap. So min heap is basically keeping track of the smallest interval based on the size of the intervals, and we want to make sure that that interval is also containing the query number. So this question, it doesn't give us the intervals in sorted order, and it doesn't give us the queries in sorted order, so we're going to have to sort that ourselves. So first of all, let's sort intervals. Intervals.sort, the key should equal to lambda x 0. And the answer to the query, so query is not going to be sorted, so we're going to sort it, which means it messes up the order of our answer. So instead of answering every query one at a time, we're going to answer the query in sorted order, and then record that answer to the query in a map. So let's call that map query answer. This is going to be a dictionary or a map in Python. So what this does is it records the answer. For example, query answer of 2 is going to be 3, and it records that in the dictionary, so we can return this query in normal order, not sorted order, so our output is correct. Now we also want to keep track of which interval we're currently looking at, because intervals are now going to be sorted based on their start time. So we're going to iterate through the queries, which means we have to keep an index for which interval we're looking at. So let's call that index I, and it's going to be starting at 0. So now for query, in sorted, query wants to be sorted, so sorted queries. So now we have our intervals. We don't have anything on our min heap. So which queries should be in the min heap? Well, we should add all the intervals that start before the query. So for example, 1, 4 and 2, 4, these two start before the query at 2. So we should add these into our min heap. So while I is less than len intervals, so while there's still intervals to iterate, and intervals at index I, 0, 0 is going to be the start time. While the start time is less than equal to the query, that means we want to include that in our query. We'll worry about the end time later when we actually get the value. So start, and we can declare these variables. They're going to be the start and end of the interval. So intervals at I, 0, intervals I, 1. So this just makes our life a little bit easier. And we want to push this into our min heap. So for min heap, we're going to use the Python library heapq. So heapq.heap push. We push into the min heap, and what we push, first of all, we're going to compare the size of each interval. So the size is going to be the end minus the start plus 1. That's how the question defines the size, right minus left plus 1. And something else that we want to push into our min heap is going to be the end index of our interval. Because when we're looking at the min heap, for example, we pop an element out of the min heap, but that interval already ended. that means we can't return that as our query answer. We need to look at another one that is perhaps longer but hasn't ended yet. So these are the two things we're going to push into our min heap. Let's actually record that. So this is going to be size and also the end time. So now while len min heap is greater than 0, so while there's elements in the min heap, we want to make sure all the elements in the min heap are going to be valid ones. In other words, they haven't ended yet. So and min heap 0, 1 is less than query. So 0, 1, this is going to be the end time of the smallest element in the min heap. So if this 0, 1 is smaller than what query is, that means this interval already ended. So what happens if this interval already ended? Then it can't be the answer. So we want to pop it from the min heap. It can't be the answer to this query or any future queries because queries is now sorted. So we want to get rid of this interval forever. So heap q dot heap pop out this interval from the min heap because this interval is no longer needed. So now the minimum at the min heap could be 0 or it could have elements, and the minimum element is going to be a valid one because we added it only if it's smaller than query, and we would have popped it if it ended before query. So this means the minimum element in the min heap is going to be including query. So the start is less than query and the end is going to be greater than or equal to query. Sorry, the start is smaller than or equal to query and the end is going to be greater than or equal to query. So in other words, it bounds query. So we should first check if min heap is 0. So if len min heap equals to 0, this means the query is not in any interval because there's no intervals that bound query, in which case we want to return -1. So query, instead of adding it to our answer directly, we want to add it to our query answer because our list of queries is going to be sorted, and so we can't actually keep the order. So query answer at query is going to equal to -1. We can't find anything. Otherwise, that means we found something. So query answer at query, this is going to be min heap 0, so the smallest element, and we want to return the size. So remember index 0, this is going to be size, so min heap 0 at 0. So now we've gone through every query, answered it. It's either -1 or the length of the smallest valid interval. So with that, we have our query answer filled out. Now we want to return the actual answer, which is in the order that queries was given in. So our answer should be, what should we answer? For q in queries, we should be answering the answer of our query. So query answer at q for q in queries. This is our answer, and we can return that answer. Let's try running that. Oh, I realized I forgot to increase I by 1, so I plus equals to 1 here. That's why we have a memory limit exceeded, because we keep pushing without increasing the interval, or the index of the interval. So let's try running that again. Cool. So that's accepted. Let's try submitting it. Nice. So this question is a bit harder than the previous, all the other interval questions, because it's no longer just caring about whether or not something is overlapping. Instead, it's taking a query and looking at the smallest interval that actually includes this query. So because we're trying to look for the smallest interval at a reasonably quick time, we can take advantage of our min heap. Min heap can find the smallest element, and the smallest element will always be at index 0. But the tricky part to this question is that we need to make sure that min heap only contains queries that are valid. So we should only add intervals to our min heap if they start before or equal to the query, and we should get rid of them if they end before the query. So whenever we're looking for a query, the minimum element in the min heap should always be valid, or should always include query. And then we can add that to our answer, or our query answer. And if we can't find any, then we want to add -1 to our answer. And then we basically restore the order by using for q in queries and then searching query answer. This is going to be a map, so this is going to be constant time. So this question, a little bit more difficult, but still reasonable because we're taking advantage of min heaps that we talked about before and using sorting and similar approaches like all the other interval questions. So that's it to this question, and that's it for this video. Thank you guys so much for watching. Hope you're able to learn something, and I'll see you in the next video.